Hello everyone, this is the automation here, and today I'm going to teach you how to use these two comparison instructions, which are greater than equal to and less than or equal to. So, if you don't know how to use these two comparison instructions in PLC programming, then watch this video till the end to get the concepts. So, let's begin. But before that, you need to like this video and subscribe if you want to learn basic concepts of PLCs. So, let's begin. So to explain these comparison instructions, I have two different industrial applications, one for greater than or equal to and another one is for less than or equal to. So first we will take the example of greater than or equal to. And the example goes like there is this wood cutting machine which is running continuously in bypass mode, neglecting all the maintenance alarms. So what's happening here is every time the machine generates a maintenance alarm, this operator is neglecting that alarm and running our machine in bypass mode by using this bypass push button. But the problem here is this operator is misusing that bypass push button, like he has the instructions that the machine should be stopped after every three maintenance alarms, which are important to run our machine efficiently. But this operator is neglecting those alarms and running this machine continuously bypassing those alarms. So to resolve this issue, we are going to mount a lamp indicator on the machine which has three colors: yellow, orange and red. So whenever the machine generates its first maintenance alarm, the yellow lamp will start to glow, and whenever the machine generates the second maintenance alarm, the orange lamp will turn on, and after three maintenance alarms, the red light must be on and our machine should stop so that the maintenance engineer can repair the machine, and the reset button will reset the lamp by which all the three lamps should turn off. So this is the simple example where we can use the greater than or equal to instruction. So let's begin. So to create this program, we need to add some rungs in our program like this. So I'm going to add four rungs in our program, and in first rung, I'm going to add one contact and one counter, which is up counter, which is going to count the alarms. And in these three remaining rungs, I'm going to add one comparison instruction, which is greater than or equal to one here and here. And I'm going to add three output coils in these three rungs like this. So I'm going to add one output coil here, here, and here. And to reset this counter, I need to add one another rung in our program. So I will add one another rung down here, and I'm going to add one contact here, and I'm going to add one reset coil in this last rung, and I'm going to add one branch instruction here. Put this reset coil inside the branch. We will use one unlatch instruction here, and I think I need to add one branch instruction here and put this output coil inside it, and I'm going to add one unlatch instruction here. So now I'm going to address all these instructions. So now we have addressed all these instructions, in which this contact will be our maintenance alarm, which is denoted by this B3 colon 0 slash 0, and we are going to count these alarms using this counter. So every time the machine generates a alarm, our counter accumulator value will increment by 1, and that same accumulator value is being compared here, here and here using greater than or equal to instruction. So whenever our accumulator value is equal to 1 or greater than 1, our yellow lamp will be turned on, and whenever our counter accumulator value is equal to 2 or greater than 2, our orange lamp will be turned on. And whenever our counter accumulator value reaches the value 3 or goes beyond 3, our red lamp will be turned on, by which our whole machine will be stopped and our operator cannot bypass the alarms and run our machine after three alarms. And after that, the maintenance engineer will come to resolve the issue, and he will resolve all the issues in the machine, and then he will simply press this reset button by which our counter will get resetted. By resetting the counter, the accumulator value will go to 0, and 0 is less than 1, 2 and 3. So that's why our red lamp, orange lamp and yellow lamp will become off, or they will stop glowing, and our machine will be ready to run properly. So let's see how our program works. So for that, we need to download and run. So let's suppose our machine is running properly and it has got its first maintenance alarm like this, and our yellow lamp has turned on because our counter accumulator value has reached 1, and which is equal to the source B of this greater than or equal to instruction. So that's why the yellow lamp is turned on, and now our operator will bypass this alarm, by which our yellow lamp will be as it is. But whenever our machine generates the second maintenance alarm, the orange lamp will be turned on because our counter accumulator value has reached the value 2, which is equal to the source B of this greater than or equal to instruction. So that's why our orange lamp has turned on, and since our accumulator value is greater than 1, so that's why our yellow lamp is also turned on. So as we know, our operator is going to bypass this alarm also. So that's why he will press the bypass button, by which our machine will be running again in bypass mode. But after some time, our machine is going to generate its third maintenance alarm, which is going to be here like this, and our accumulator value will go to 3, and our red lamp will be turned on because our counter accumulator value is equal to the source B of this greater than or equal to instruction. So that's why our red lamp, orange lamp and yellow lamp will be turned on, and our machine will go in shutdown mode, and our operator will call the maintenance engineer, and whenever our maintenance engineer repairs the machine, he will simply press this reset push button, by which our counter accumulator value will go to 0. So let's see how it works. So we will press the reset button, by which our counter accumulator value will go to 0, and 0 is less than 1, 2 and 3. So that's why our red lamp, orange lamp and yellow lamp will be turned off. So let's test this program again to see how it operates whenever we reset the machine. So now that you know we have resetted this machine, and now our machine is running healthy, but whenever the machine generates its first maintenance alarm again, that alarm will be high here, and our counter will count 1, by which our yellow lamp will be turned on, and our operator is going to bypass the system, and our machine will run in bypass mode with its first maintenance alarm. But after some time, the machine generates the second maintenance alarm, by which the orange lamp will be turned on using this greater than or equal to instruction, and our operator is going to bypass the system, by which our machine is running in bypass mode while suffering from two maintenance alarms. But whenever the machine generates its third maintenance alarm, the red lamp will turn on and our machine will stop, so that the operator should call the maintenance engineer. So maintenance engineer will simply repair the machine, and he will simply press this reset button, by which our machine will be resetted and our all three lamps will be turned off, and our machine will be ready for its further operation without any maintenance alarm. So I hope you got the point how we can use greater than or equal to instruction in our program, and how greater than or equal to works in actual program. So now let's move further to our next comparison instruction, which is less than or equal to. So to explain the less than or equal to instruction, the example goes like, there is one bottle capping machine which has a container which stores the caps of the bottle, and we need to monitor the number of caps remained in the container. So for that, there are these two sensors placed at the entry and the exit of the container. Like whenever a cap enters the container, the sensor will detect that cap and our counter will increment by 1, and every time the cap goes out of the container, then this sensor down here will send the signal to our counter, which will decrement the count by 1. So now what we are going to do is we are going to compare the count of the bottle caps using less than or equal to instruction, and going to generate one alarm whenever the number of caps remained in the container becomes 5 or less than 5. So by generating this alarm, we will decide whether we stop the production or put some more caps in the container. So let's create this program using less than or equal to instruction. So to create this program, we need to add 3 rungs in our program. So I will add 3 rungs in our program, and in our first rung, I am going to add one NO contact here, and in second rung here, and in our first rung, I am going to put the up counter, and in second rung, I am going to put the down counter. And in this third rung, I am going to add one comparison instruction which is less than or equal to instruction. So I have added this less than or equal to instruction here, and I am going to add one output coil in this third rung, two branch instruction in our first rung and second rung like this, and I am going to put this up counter and down counter inside the branches, and I am going to drag the unlatch instruction here and here. So now I have added all the instructions, and now I am going to address all these instructions. So now I have addressed all these instructions, from which this NO contact will be our entry sensor and this NO contact will be our exit sensor, and whenever the bottle cap enters the container through the entry gate, this entry sensor will be high, by which this up counter will increment the accumulator value by 1, and whenever a bottle cap goes out from the container, this exit sensor will be high, by which this down counter will decrement the accumulator value by 1. And since we are using same counter address for this up counter and down counter, the accumulator value will be same for up counter and down counter. Like whenever this up counter is working, the accumulator value will increment by 1, and whenever the down counter is working, then our accumulator value will be decremented by 1. And that same accumulator value is being compared here using less than or equal to instruction, and in our source B I have put the value 5 because I want to generate one alarm whenever the accumulator value or our number of caps in the container becomes 5 or equal to 5. This output coil will be high. So let's see how it works. So download, and so now our program is in running condition and our counter accumulator value is at 0, which is less than 5. So that's why this output coil is initially high. So I will just go offline and I'm going to put the value 10 in the accumulator value because we are assuming that the container has 10 caps initially. So I will download this program and run. So now our counter accumulator value is at 10. So whenever a cap enters the container through the entry gate, the entry sensor will sense that cap and our accumulator value will be incremented by 1 like this, and whenever a cap goes out from the container, this exit sensor will sense that cap, by which our down counter will decrement that same accumulator value by 1, like it has gone to 10 again. And if I take out one another cap from the container, then our accumulator value will become 9, and if I take one another cap out from the container, then our accumulator value will be 8, and one again, then our accumulator value will go to 7, then one again, then it will go to 6. And now if I take out one another cap from the container, the accumulator value will go to 5. And since we are generating this alarm whenever the count goes to 5, so this alarm will be generated now. So I will just take out one another cap from the container and our accumulator value has reached the value 5. So that's why our accumulator value and source B have become equal and our alarm has generated here. And if I take out one another cap from the container through the exit sensor, the accumulator value will go to 4, and 4 is less than 5. So that's why our low alarm is still high because of this less than or equal to instruction. So if I add one another cap in the container, the accumulator value will go to 5, and still our alarm is high because our accumulator value and source B are equal. And if I put one another cap inside the container through the entry gate, the accumulator value will go to 6, and since the accumulator value is greater than source B, our alarm has been disabled. So this is how less than or equal to works. Like whenever our source A is less than or equal to source B, our output coil will be high, and whenever our source A becomes greater than source B, our output coil will be turned off. Like now our source A is greater than source B, so that's why this low cap alarm is off. And whenever I take out one cap out from the container, our accumulator value will go to 5, and 5 is equal to source B, which is 5. So that's why our low cap alarm is high here. And if I make our accumulator value less than 5, then also our low cap alarm will be high. So this is how less than or equal to works. I hope you got the point and took the notes. And if you have any queries regarding less than or equal to or greater than or equal to, then feel free to ask in the comment section. I will always be there to answer your questions. And if you learned something new today about PLC programming, then make sure you hit that like button and subscribe if you are interested in PLC programming or industrial automation, and share this video to your friends and colleagues who are also interested in PLC programming. So with that being said, I will see you in the next video in which we are going to learn how to use the last comparison instruction, which is limit. So stay tuned. Bye. By the way, some of you ask me why I use these unlatch instructions for the binary bits. So let me tell you that whenever I'm using a binary bit for a short-term application like this one, like I just want a trigger pulse for this counter, so that's why I'm using this binary bit here and here for the unlatch instruction. So whenever I'm toggling this binary bit will go through this rung like this, and it will reach to this up counter, and our up counter will operate on that signal, by which this accumulator value will increment by 1. And while the signal is going inside the counter, it is also going down here to this unlatch instruction, like it is working for counter and also for unlatch instruction, so that I should not go here and untoggle this binary bit. So this is the simple reason behind this unlatch instruction. Like whenever I don't want to untoggle the binary bit, I will simply use a unlatch instruction here, which will reset the binary bit whenever its primary work is done. Like here, the primary work of this binary bit is just to send one trigger pulse to this up counter, and by sending the high signal, it has completed its work. So that's why I have unlatched that binary bit here using a unlatch instruction. So this is the simple reason. See you again. Bye.